everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Thank you for tuning in to my video. God bless you. Please, before we go into today's exercise, do not forget to like, share, subscribe to my YouTube, and also kindly click on notification button so that you can have more of my video. Today we are taking a topic relating to application of a vector. In my former video, I've explained what vector is all about. So today we want to dwell into the application of vector, and the two aspects we are going to deal with today are: case 1 is to find angle theta between two vectors. Case 2 is to find the unknown coordinates in a given parallelogram. So I'm going to introduce us first in the first video on the derivation of related formula. Then the subsequent video will also dwell on how to use this formula to solve some exercise. So we are starting now. The angle between two vectors. Let's say we are given these two vectors A at an angle theta to vector B. Let's assume that vector A is in terms of a unit vector is described as 3i plus 4j. Now let's say vector B is described by unit vector minus I plus 5j. Now, what I mean by unit vector is this. Let's say we have the y-axis and we have the x-axis. The direction along the y-axis is vector j, and the direction along the x-axis is vector I. Each of these j and I are called unit vector because their magnitude is 1. The coefficient here in front of j is 1, and the coefficient here in front of I is also 1. So the two vectors are at right angle to each other. Now, if I want to indicate vector A in this diagram, that means I move 3 units along the x-axis. So from 0 to this place will be 3. So that's why this one is 3i. Then I move 4 units along the positive side of the y-axis. That's why this place is 4j. So my movement now is this. If I move 3 here, then I move 4 here. That means the resultant of this vector is the vector A that we have here. And then, so that means if I start from this fixed point of origin, and if I move this way, it's equivalent to moving this way and this way. That's why vector A is 3i plus 4j. So the same thing is applicable to what we have here. We can equally display this one on the Cartesian coordinate system. That's not what we are dealing today. We just want to find the angle between two vectors. We normally use what is called dot product. Dot product. The dot product of vector A dot B is given as the magnitude of vector A times the magnitude of vector B, then times the cosine of angle theta between them, the angle between these two vectors. Now, how do we find the magnitude of vector A and B? We normally use Parallelogram theorem in respect of the coefficient of the respective vector. For instance, the coefficient of vector A are 3 and 4. So we just say the square root of 3 square plus 4 square using Parallelogram theorem times the square root of the coefficient of B is minus 1 and 5. So I have minus 1 square plus 5 square. Then we say cos theta. Now, how do we do A dot B? Our A is 3i plus 4j. I write it 3i plus 4j. We say dot minus I plus 5j. So in order to open these brackets using dot product, we multiply like terms. Like this I, 3, we have I here. The coefficients are 3 and minus 1. So we multiply the coefficient 3 times minus 1. Then for the j, the coefficients are plus 4 and plus 5. So we multiply 4 and 5. So then it will be equal to here, the square root. 3 square is 9 and 4 square is 16 times minus 1 square is positive 1 plus 5 square is 25 cos theta. 3 times minus 1 will give us minus 3 plus 4 times 5 will give us 20. Then this one give us square root of this is 25. 9 plus 16 is 25 times 1 plus 25 give us 26 cos theta. Square root of 25 is 5, so this one become 5 root 26 cos theta. Minus 3 plus 20 will give us 17. So to find theta, we take the arc sine. Okay, let's make cos theta solve a formula by dividing both sides by 5 root 26. So we have 17 divided by 5 root 26 is equal to cos theta. To get theta, we take the arc sine of the expression we have here. So theta will be cos arc of 17 divided by 5 root 26. So at this stage, we go to the calculator. In the calculator, we press the second function of the cosine. So we press 17 divided by 5 root 26. That's 5 square root of 26. So we are going to have roughly 48.18 degree. This one is to find the angle between two vectors. My second video now is how to find the unknown coordinates of a parallelogram. So here now, I'm going to clean up how to find angle between two vectors and then get an expression for how to get the expression for the unknown coordinates in a parallelogram. So here now, I look at this parallelogram. The two sides are of the same magnitude. This side here, side AD, is of the same magnitude with side BC. That means the vector AD must be equal to vector BC. So, and the same thing is applicable to this other side of this parallelogram. The vector AB must be equal to vector DC. So let me start with this now. How do we find this particular unknown coordinate? We say vector AD is equal to vector BC. Vector AD is equal to vector BC. How do we find vector AD? To find vector AD, we just simply take the respective the difference in respective coordinates of the points on A. So we take the difference in the coordinates x, that's the abscissa. Then the difference in coordinate y, that's the ordinates of the side AB. We say is equal to the difference in the abscissa and the difference in the coordinate of this other side of the triangle, vector BC. So in my diagram, if you look at vector AD here, the difference will be x2 take away x1. This particular difference, x2 minus s1. Then for here, we have a y2 minus y1, which is equal to the difference in the respective coordinates of the side BC. For the abscissa, we have x3 take away x, s3 take away x. Then we have y3 take away y. So that's the formula that we can use to find the unknown coordinates x and y. Now let's quickly go to solving a particular exercise. Look at this expression that we have here. The question says find the unknown coordinates by vector method of this. We are given the coordinates 1, 8, 1, 3, 2, 5 and sy for this particular parallelogram. So we have to find the unknown coordinates. We can simply go to this formula that I have established. So what I'm going to do now is I will label this place as my x1, y1, this place as my x2, y2, then this place as my x3, y3. Then if you look at this formula, x2 here is minus 2. So I will just put minus 2 there. Then minus s1 here is 1. Then for the y2 here is 5 minus y1 here is 3. So for this side, we say is equal to x3 here is 1. So we put 1 here minus x. Then y3 in this diagram here is 8. That's going to be 8 minus y. Now, because these two vectors are equal, their corresponding coordinate should be equal. Minus 2 minus 3 minus 1 here will give us minus 3. And then 5 minus 6 will give us 2 here. Then here we still have minus 1 minus x, 8 minus y. So the respective coordinates must be the same. For the abscissa, we have equation 1. This expression here should be equal to this. So we are having minus 3 must be equal to 1 minus x, making x the subject of formula. If I take this minus x to that side, become positive x. Taking minus 3 here, become 1 plus 3, which is 4. So that means the abscissa or no abscissa in this question here is 4. Now to get the ordinates y in this question, we equate this side of the equation together. So we have 2 is equal to 8 minus y. To make minus y sort of formula, I take it to this other side. I have y. Then when we take plus 2 to that side, become minus 2. So 8 minus 2, which is 6. So that means the coordinate xy can now be written as, for my x, I have 4. And for the y, I have 6. So the unknown coordinate for this question here is 4 and 6. Thank you so much for your time, listening to my video. Once more, please do not forget to like, share, subscribe, and click on notification table button for more of my video. Have a nice day. Bye.